was in previous class we have discussed few basic tools which are used for solving the problems in coordinate geometry. From this class, we will start this new topic, that is locus, and it has a vital role in coordinate geometry. So, before discussing this topic, you should have a sound knowledge of basic tools which are discussed in previous videos. So all of you must watch the previous videos of coordinate geometry, and from there you will get the basic tools which are now we will apply in solving the problems further. Now, boys, let us start this topic, locus. What this word stands for? So, first of all, we should define the locus. It is defined as a path traced out by a moving point. Locus is nothing but a path, and that path is traced out by a moving point. Now, here, what we mean with this word path and what this locus stands for, that we will discuss. Boys, you know that suppose here, take an example. Suppose here there is a fixed point. This point A, it is fixed. Now suppose a point, say this point P, is moving. Now this point P is moving. It means that this point P during its motion acquires this position, though it moves at several positions during its motion. Now, if we apply a condition on the motion of this point P, say the condition is the distance of this moving point P from this fixed point be always 5 units. Say this distance is always 5 units. Now, if this distance is 5 units, the path on which this point P is moving, that path is called the locus of this point. Now, obviously, you know, if this distance is fixed 5 units, then the next position of this point P will be on the circumference of a circle whose radius is 5 units. Observe it. If this is the circle, and on this circle, anywhere this point P takes its position, its distance will be 5 units always. Whatever be the position of the point P on the circumference of the circle, its distance is always 5 units. So, the path which it traces out is nothing but a circle. It is a circular path. And boys, this circle is defined as the locus of this moving point P. So, the locus is nothing but a path, and that path is traced out by a moving point, and under that point, that moving point moves under some restrictions, few restrictions are imposed on that moving point. If restrictions are not imposed, you will unable to find the path of that moving point. Why? You see, if it is asked by your guardian that go to school, then from your home to school, you have a path and consider himself as a point. Now, the path on which you will travel will define your locus. So, locus is nothing but a map on Google. When you book a car or you hire a car for some destination, you will find that the directions are given in some zigzag manner like this. That from here to here you have to travel. Then Google Map will show the direction in this manner. So this is nothing but the locus. So locus is nothing but a path, and that path is traced out by a moving point under some restrictions. If you don't know that you have to start from here and where to go, where to end your journey, if you don't know, then it is not possible for us to determine your locus. So always remember what locus is nothing but a path. And in coordinate geometry, each and every path has got an equation, whatever be the path. But I am just giving you an example that in class 9 and 10, you have drawn the graph of few equations. Say, if asked by your teacher that draw the graph of 2x plus 3y is equal to 6. For drawing the graph, you have taken few pairs of values of x and y, and that pairs of values of x and y are plotted on graph. After plotting those values on graph, you will get a straight line. So this figure you will get. What it means? That this is the path traced out by a moving point under the restriction that 2 times abscissa plus 3 times ordinate is always 6. If 2 times of abscissa, x is abscissa, I have already told you, if 2 times abscissa and 3 times ordinate is equal to 6, and if a point moves under this restriction in this Cartesian space, then the path which traces out by that moving point is this line. And you have drawn the graph of this line. So if this is the locus, this implies that there is a point P and it moves at several points on this locus under this restriction. Now, the basic thing is that each and every locus has a figure, and each figure has got an equation in terms of x and y. Always, because we are discussing here coordinate geometry of 2 dimensions, so we have 2 characters are important. The first one is x, the second one is y. So whatever we will get, the relation between this x and y, that relation always represents the locus. But if someone asks that what will be the locus of a moving point which moves in such a manner that its distance from 2 fixed points, A and B, 2 fixed points, be always equal. 2 fixed points means here A is 1 point, B is 1 point. They are fixed. They will never move. Now there is a point. Say P is a point. Now this point P moves. Under the condition that the distance of this point P from A as well as the distance of this point P from B be equal. Now what path this P point will follow? You have to imagine, you have to think. So, what to do? If you join this PA, and if you join this PB, this PA is equal to PB. Now, let us take one more position of this point P here. Now, again, you find that these two lengths should be equal. Here, here. Say, if we have a midpoint of this line segment BC, say if we have a midpoint of this line segment BC, then point P must pass through that midpoint so that whatever is the position of this point P, its distance from A is equal to its distance from B. So this figure which you will get, that figure will represent the locus of the moving point under this restriction. And this locus is nothing but the perpendicular bisector of the line segment joining the 2 points A and B. Perpendicular bisector of the line segment joining 2 points A and B. And if this is a line, then point P must move on this line to satisfy that particular condition. So, from this discussion, we have an idea that locus, the word locus, it stands for a path, and that path has got some equation we will discuss later. Now, let us try a few more examples to find the path traced out by a moving point. But suppose if it is asked that what should be the locus of the center of the wheel of a moving car moving on a smooth plane. Just think over it. Remember, we are discussing here analytical geometry, and this analytical geometry is totally based on thinking, thoughts. So, what was the question? That what is the locus of the center? Locus of the center of the wheel. Will of a car moving on a smooth plane. Smooth plane. Now you see boys, suppose this is the plane and say this is the one of the wheel of the car. One of the wheel. Now, during its motion, what about the position of center? You can observe, center is here. So, if car moves, then the center will move on a line which is parallel to that smooth plane. This word is important. The plane should be smooth. If plane is not smooth, you will get a zigzag curve like that, because that wheel must be up and down during its motion. So if the plane is smooth, then in that case car will move here, the center of the wheel, center of any wheel. Now that will move on a line. So what locus you will get? The locus is nothing but a straight line which is parallel to the plane. And at a distance equal to the radius of the wheel. In this way, you can imagine different types of locus, and that locus has got some figure. Here, we may have different types of locus, and was each and every figure what you observe here in coordinate geometry or else in nature, each and every figure has got an equation. Each and every figure. So we confine our discussion to geometry of 2 dimensions. So that's why in two-dimensional geometry, by choosing two axes, x and y axis, if you draw any picture, any zigzag curve, say this curve, so this curve has got some equation. Some equation means a relation in terms of x and y. And after getting that equation, we have to choose different pairs of values of x and y. And not only three values. Three values are restriction are in class 10. But you can take 300 values, 3 lakhs values. You can choose different values of x and y and plot these values on this graph paper. Join all these values by freehand or by means of a scale. This will depend on you. So, if you join all these values, you will get a curve, get a picture. That picture is called the locus of a particular moving point which moves under certain conditions imposed. Now, as few important different types of locus for science students, we can discuss that it may be cycloid, it may be asteroid, it may be nephroid. There are different locus. These are the different kinds of locus which are obtained by moving a point under some restrictions. So we will discuss each and every kind of locus in due course. Let us start how to find the locus of a point. Because in order to find the locus, always, or to solve the problems based on locus, few steps you have to follow. And that steps you must keep in mind for solving the problems based on locus. Now, what are those steps? You see here. Step 1. Step 1. Let P in the bracket HK be the position of a moving point at any instant. At any instant. Satisfying the given locus. Given locus. Let PHA be the position of a moving point at any instant satisfying the given locus. So this statement you have to write for all the problems based on locus. Yes, you can change the name. Instead of P, you can write Q, you can write R, this will depend on you. But here we have taken P with the position of a moving point at any instant. Now, boys, remember it. In few books, they have written directly that P, XY is the point. Remember, do not follow this. This is a wrong way to find the locus. Remember it. Do not take P directly as XY. Always try to particularize that point, and after taking the particular position, we have to impose the conditions. So, avoid writing PXY is the moving point. Remember it. Now, step 2. Step 2. Apply the given condition. And find a relation in H and K. Remember, I have already told you that locus is formed under some restrictions. Few conditions are given to you. So, first of all, you take PHK be the position of a moving point at an instant, and then apply the condition under which that point is moving. Now, if you apply that condition, here is your importance of basic tools which we have discussed earlier. Now, apply those basic tools to get a relation in H and K. Conditions, this will changes from problem to problem. You have to check out the conditions, that under what condition this point is moving, you have to apply that condition. And the third state 3. This is the general state 3. Now, therefore, you can write, therefore, the required equation to the locus. Remember it. This word you have to write for all the problems. Therefore, the required equation to the locus is, just replace h by x and k by 1. Means whatever relation you get here, from that relation you must write this statement, therefore the required equation to the locus, and then below it you must replace h by x and k by y. Because the condition which is satisfied by a particular point hk, and if the same condition is satisfied by all the moving points, say general coordinates xy, okay, then that will be your locus. So here we are generalizing hk to xy. So this your locus, equation to the locus will always exist in terms of x and y. So these 3 steps you have to follow, boys, for finding the locus of any point. Now let us start a problem on it. Find the locus. Find the locus represented by a moving point such that twice its abscissa is always equals to 2 more than its ordinate. Twice its abscissa is 2 more than its ordinate. Now boys, what to do? What I have told you, you have to write the first step. Solution here we are writing, let P HK be the position of a moving point at any instant satisfying the condition of locus. Let PHK be the position of moving point at any instant satisfying the given condition you can write, or condition of locus. This will depend on you. Now, therefore, abscissa What about the abscissa of the point? It is H. Ordinate. What about the ordinate of the point? It is K. Now what is given? Twice its abscissa. That is by condition. What happens? Twice the abscissa, 2H, is always equal to 2 more than its ordinate. That is K plus 2. K plus 2. So this is the relation is H and K by applying the given condition. Now what to do? We have to generalize this result. Therefore, equation to the locus is, what happens? In the place of H we have to write X. In the place of K we have to write Y. So what would the condition? 2X is equal to Y plus 2. So this is your answer. But when you draw the picture of this equation on the graph paper by choosing 2 x's, and if you find the value of y as 2x minus 2, take the value of x, then y, you can choose different pairs of values and plot those values on graph, you will find that twice its abscissa for any point is always 2 more than its ordinate. So boys, this is the beginning of this topic, locus. I think all of you can easily understand. So always use earphone and use mobile in portrait way to visualize all the problems written here on the board. So we will discuss this topic, we will extend this topic in the next class. So thank you boys.